Hi CBSE ninth graders, welcome back. This is Pooja and I hope you are doing good. और ये हमारा सेकेंड लेक्चर है ग्रेविटेशन पे। आज हम डिटेल में पढ़ेंगे ग्रेविटेशन चैप्टर में आगे के टॉपिक्स के बारे में। तो सबसे पहले व्हाट वी आर गोइंग टू डू इन टुडेज क्लास, लेट्स अंडरस्टैंड दैट थिंग। पहले हम पढ़ेंगे रिकैप जो हमने लास्ट क्लास में किया था, देन डिपेंडेंस ऑफ ग्रेविटी ऑन डिस्टेंस, किस तरह से ग्रेविटी डिस्टेंस पे डिपेंड करती है, किस तरह से ग्रेविटी मास पे डिपेंड करती है, इंपॉर्टेंस क्या है यूनिवर्सल लॉ ऑफ ग्रेविटेशन, क्यों हम स्टडी कर रहे हैं, एंड फाइनली दैट इज द वी आर गोइंग टू स्टडी the Kepler's law. Okay, so these are the topics which we are going to cover in today's class. Now on this side you can see a beautiful picture, like we have a spray bottle, और आप देख सकते हैं किस तरह से जो स्प्रे बॉटल है, जैसे जैसे आप डिस्टेंस दूर जाता जा रहा है इसकी इंटेंसिटी घटती जा रही है, राइट? सो दिस पिक्चर इज स्पेशली फॉर माय विजुअल लर्नर्स to understand the inverse square law, which we'll be talking about like soon in this lecture about the gravitational force. So next, okay, so there's a quick recap. Okay, so in the last class of gravitation, अगर आपने नहीं देखा है तो just please go through that. Okay, हमने centripetal force के बारे में explain किया था बहुत अच्छे से. Then we have studied about the universal law of gravitation, क्या होता है, right? आपको पता है, आगे भी हम अभी बात करेंगे. Gravitational constant significance क्या है, उसका क्या importance है, dependence of gravitational force on the distance, किस तरह से वो distance पे depend करता है, तो ये सारे topic हम discuss कर चुके हैं. Next. So before I go ahead, let me tell you the basics, what we are going to do in today's class. Let me tell you that. So here we go. So what we have done till now is that we know that force, gravitational force F, is given as G M M divided by d square, right? What is this G here? G is the gravitational constant. M, they are the product of masses, both masses, whether the masses are small or big, depend on the case. Then D is the distance between two masses, right? And this is the gravitational force. This we have already studied. We will be studying in detail. And from these, like this relation, we are clear that this force we are talking about, the gravitational force, is directly proportional to the product of masses, and it is inversely proportional to the square of the distance, right? So these two relations mainly we have to understand, like how does the gravitational force depends on the product of masses, and how does gravitational force depend on the square of the distance. Now, say for example, first we are going to study in detail about this thing, that is how this force depends on the, this is also called inverse square law. How does the gravitational force depend on the square of the distance? Say for example, I'm taking this d, I have some d dash is equals to, say for example, d by 2. Okay, so in that case, what will be the gravitational force? So let it be f dash. What will be the value of this f dash? So how you will do that? Simply, we know that f is equals to, from this relation, that f is equals to gmm divided by d square, right? So what happens if we put the value of d dash, because we have to find out the value of f dash here. So f dash will be equals to gmm divided by d dash square. Okay, now if you'll put the values here, that is d dash is equals to d by 2, you will get g m divided by d square, and this will come out to be 4 here, right? So I can say from this relation that f dash will be equal to 4 times f, right? So what happens when the distance got decreased, the gravitational force got increased, right? Similarly, what will happen if we'll consider, say for example, we are taking d dash is equals to d, or we are taking d dash is equals to 2d, 4d, and whatever we are taking it. So किस तरह से अगर आप distance बढ़ाते जाते हो तो ये gravitation force जो है बढ़ेगा या घटेगा, that we have to understand. Okay, and one more thing which we are going to learn here is that because f is directly proportional to the product of masses, right? So from this relation, we will try to prove that whenever we are taking, say for example, we are taking mass m is equals to 1 kg, and this is also we are taking at 1 kg. So what will be this gravitational force? Okay, similarly, if m is equals to, say for example, 1 kg, or say for example it is 100 kg, okay, and the small m is 1 kg. So in that case, what will be the value of gravitational force. So and so on. If we have a very huge mass, that is the mass of the earth if we are considering, and a mass of us, say for example I am there, so then what will be the gravitational force? So in this lecture mainly we have to study that how this gravitational force किस तरह से वो distance पे depend करता है और किस तरह से वो mass के ऊपर depend करता है. So the gravity and the distance, okay, the gravity and the distance, as I can see the inverse square law, it is also called the inverse square law. Why it is called inverse square law? Because F is, we say, we'll prove with all these data that F is inversely proportional to the square of the distance. So that's why it is called inversely proportional. So inverse square law, because it is square of the distance. Okay, so it is called inverse square law. So when d dash is equals to d by 2, as we have seen earlier, f dash will be equal to 4 times f. Similarly, you can prove with d dash is equals to 2d, then f dash will be equals to f by 4. Similarly, when d dash is equals to 3d, f dash will be f by 9. So you can see how this force keep on decreasing as you keep on increasing the distance. जैसे जैसे आप distance बढ़ाते जा रहे हैं, पहले आपके पास में ये 2D था, फिर ये 3D हो गया, तो जैसे जैसे डिस्टेंस बढ़ता जा रहा है, फोर्स जो होगा वो डिक्रीज होता जा रहा है, राइट? So what we have learned here, हमें क्या समझ में आया? From this we can conclude that this force of attraction between the bodies varies inversely as the square of the distance between them. In other words, I can say the distance, as the distance gets bigger, जैसे जैसे distance बढ़ता जाएगा, the gravitational force of attraction becomes smaller. वैसे वैसे ये gravitational force जो दो bodies के बीच में लग रहा है, ये छोटा होता जाएगा. Okay, so this is the picture which I was talking about, and this is basically telling us this is related to intensity here. But I am talking here in the gravitational force about this picture. So what you should know about this thing is that, say for example, I have a source here, okay? So, or a mass is there, Earth or whatever mass is there, and another mass is here. So what happens as this, you will keep on increasing. This is, say for example, at this point it is d, and again you will say for example you have increased this distance to twice d, and so on. So if you keep on increasing the distance, as you can see in the previous slide also, like when d dash is equals to twice d, f dash is equals to f by 4, right? So at this point, when you keep on increasing the distance, what will happen? The force will reduce to 4 times, or I can also say that if force between these, the force which was acting when the masses were here at this distance d, say for example the force was f, or f dash was equals to f dash. But what happens if the distance become twice d? जब ये twice d हो जाएगा, तो उस केस में जब हम यहाँ इस पॉइंट की बात कर रहे हैं twice d, in that case the force will become f dash will be equals to f by 4. Similarly here the f dash will be equals to f by 9. तो इस तरह से जैसे जैसे आप दूर जाते जाओगे, force जो है वो inverse square की relation में decrease होता जाएगा. So as you keep on increasing the distance, what will happen? The force of attraction घटता जाएगा. How? Like I will show you on PHET there is simulation, और उस पे भी आपको दिखाऊंगी कि किस तरह से ये चीज work करती है. Okay, there is one more interesting thing for my visual learners and for everybody to learn about the gravitational force. This is Earth, as you can see, right? And we are standing here on Earth, say for example, I am here, okay? So if you are here, you can see the force is maximum. This is observed experimentally, and then the graph was drawn, okay? So you have to, like, if you have to clear your basic concept, you can remember this graph, okay? So what is happening? So इस point पे क्या होगा? The gravitational force will be maximum. जैसे जैसे आप particular height, आप यहाँ पे खड़े हो, आप distance बढ़ाते जाओगे अर्थ से, आपकी height बढ़ती जा रही है. तो जैसे जैसे height बढ़ती जाएगी, जैसे जैसे आप दूर जाते जाओगे, gravitational force जो होगा वो F जो है वो decrease होता रहेगा, right? Similarly, what will happen if अगर आप depth में जा रहे हो, अर्थ के inside जा रहे हो, जैसे जैसे आप अंदर जाओगे तो क्या होगा? अगर ये डेप्थ है तो अंदर जाओगे तो क्या हो जाएगा? again the gravitational force will also decrease. So here the proportionality sign, we know that F is inversely proportional to 1 upon d square. And here in this case, when we are going inside the earth, here F will be directly proportional to A, as you can see through the graph too. It's a straight line graph, right? Now, now the second part. So second part is dependence of gravity on mass. किस तरह से ये mass पे डिपेंड करता है? तो हमें ये क्लियर हो गया कि किस तरह से ये डिस्टेंस पे डिपेंड करता है. जैसे जैसे आप डिस्टेंस बढ़ाते जाओगे, ग्रेविटेशनल फोर्स घटता जाएगा. इट्स सिंपल टू अंडरस्टैंड. बट वो डिस्टेंस जो है वो इनवर्सली प्रोपोर्शनल नहीं है, केवल स्क्वायर ऑफ द डिस्टेंस है. ओके, नाउ वी नो दैट F इज इक्वल्स टू GMM डिवाइडेड बाय d स्क्वायर. अब अगर हम मासेस की बात करें, जैसे हमने पहले भी जब लेक्चर स्टार्ट किया था मैंने आपको बताया था, अगर मैं ये मासेस जो हैं, अगर इनिशियली समझने के लिए इसको मैं 1 kg लेती हूँ, इसको भी 1 kg लेती हूँ, तो व्हाई देयर इज नो ग्रेविटेशनल फोर्स जब मैं 1 kg की बात करती हूँ? क्या होता है? लेट्स अंडरस्टैंड दैट थिंग मैथमेटिकली. फॉर सिंप्लिसिटी हमने d को 1 मीटर कंसिडर करा है. g इज इक्वल्स टू, ऑलवेज रिमेंबर, इट्स वर्थ टू रिमेंबर दिस वैल्यू, that the gravitational constant is given by 6.67 into 10 raised to the power minus 11. Always remember, it's a very small quantity. It is minus 11. Newton meter square kg minus 2. You don't have to mug up this unit. I hope you know how to remember this unit, okay? And then how you will calculate? You will get F is equals to G mm divided by d square, right? या जब आप वैल्यू पुट करोगे तो आपके पास आएगा 6.67 into 10 raised to power minus 11 into 1 divided by d square. So that is also 1 square, that is 1. So you will get the value as 6.67 into 10 raised to power minus 11 Newton. Now look at it. See, कितना छोटा फोर्स है, minus 11. Okay, which means it's a very, very weak force. When the masses are small, force of attraction होता है उन दोनों के बीच में, but वो बहुत weak होता है. Similarly, अगर हम बात करते हैं, say for example, अगर और इसको हम example consider करें, I have one mass which is of 1 kg, another mass जिसका मैं कह देती हूँ mass 100 kg है. So in this case अब क्या होगा? Similarly, हमने G की value, it's worth remembering, 6.67 into 10 raised to power minus 11. Okay, 6611. So unit, you also know it. Simplicity, we have considered d is equals to 1 meter. So what will be the value of F? So you can calculate it quickly. That is 100 into 1 into 6.67 into 10 raised to power minus 11 divided by d square, that is 1. That will come out to be 6.67 into 10 raised to power, this is minus 11, 10 raised to power 2. So minus 11 plus 2, it will come out to be 6.67 into 10 raised to power minus 9. Look at it. Again, it's a very, very small force. So agar I am like some person or anything which you have is of 100 kg और एक आपके सामने 1 kg की चीज पड़ी हुई है, उन दोनों के बीच में भी आप ग्रेविटेशनल फोर्स जो है, पुल जो है, वो काफी वीक होता है, वो -9 की रेंज का होता है. जस्ट इमेजिन. नाउ अब हम एक मास बहुत ज्यादा बड़ा कंसिडर कर लेते हैं. से फॉर एग्जांपल हमने मान लिया अर्थ का मास, ठीक है, and which is nearly equal to 6 into 10 is 24 kgs, and another mass जो हमारे पास 1 kg है, और ये हमारे पास अर्थ है, that is 6 into 10 is to power 24 kg है. और g की वैल्यू हम सबको पता है, d जो है 1 मीटर है. तो अब आप कैलकुलेशन करोगे तो आपके पास क्या आएगा? that is 6.67 into 10 raised to power minus 11 into mass m1 into 6 into 10 raised to power 24 divided by 1. So you will get as 6.67 into 6 multiplied by 10 raised to power 24 minus 11, right? And when you will solve this, आपको क्या value मिल जाएगी? This value will come out to be nearly, calculate करो, बताओ क्या आएगा? This will be nearly equal to 40.02, right? Into 10 raised to power, this will be 1 and 3. Okay, Newton. So look at this. If any of the object, अगर कोई भी एक मास अगर बहुत ज्यादा बड़ा है, तो उस केस में ये ग्रेविटेशनल पुल, ग्रेविटेशनल फोर्स ऑफ अट्रैक्शन भी बहुत बड़ा हो जाएगा. दैट इज 40 into 10 raised to power 13. अब ये पॉजिटिव में है. नाउ इट्स नॉट नेगेटिव. प्लीज अंडरस्टैंड दैट थिंग. नाउ This question, I think every one of you can try it. I can just give you a formula and you will be easily, just simple calculations are there. Main thing is you have to solve it by yourself. So what is given to you? Whenever the question is given to you, you have to write the given thing. What is given to you? So mass of Earth is given to me. That is 6 into 10 raised to power 24 kg. What else is given to us? Mass of the moon is given to us, that is 7.4 into 10 raised to power 22 kg. And the distance between them, D, is given to us as 3.84 into 10 raised to power 5 kilometer. This distance I can also say, please always remember to change unit. Into 10 raised to power, kilo is 10 raised to power 3. So this will become 5, 6, 7, 8 meters, right? So these are the values which are given to you. Please do calculate it and let me know what will be the value of force acting on it. And obviously in this, we are very much clear when the masses are too big, this force will come out to be a big force, right? So gravitational, here it will come into picture and you can see and observe that thing. Now what we have learned, so what's the conclusion of this thing? The conclusion of this thing is that that this law is applicable to all bodies, whether they are small or big, whether celestial or terrestrial. Also, the gravitational force between two objects of ordinary size is very small, while the force is very large when at least one of the object is massive. Agar ek bhi object massive hoga, the gravitational force will be very large. We have seen through examples. Okay, हमने ये देख लिया है. Okay. Coming to the next topic, that is importance of the universal law of gravitation. हम ये क्यों पढ़ रहे हैं, right? That is very, very important. जब भी हम कोई चीज study करते हैं, always remember the 5W rule. What is that 5W rule? That ask yourself 5 W's. 5 W's are why we are studying that. What is that? Where, from where that thing came? What, where, when, who invented that thing? And finally, what will be that W? Why, what, where, who, and when. So if I always tell my students, if you want to be thorough about a particular topic, always remember this 5W rule. Okay. So importance of universal law of gravitation, why we have studied this rule. There are a lot of application other than this, but here we have concluded few of them. Revolution of planets around the Earth, tides, in the oceans, which you see the waves, why they are formed, stability of the objects, the force that bind us to the Earth, revolution of moon around the Earth, fruits falling from the tree, daily life activity. So as you can see, there are n number of applications which you can see of this law. Okay, we have another question for you, a simple one. The Earth and the moon are attracted to each other by gravitational force. Does the Earth attracts the moon with a force that is greater, smaller, or same as the force with which the moon attracts the Earth? So are these forces, the moon which is applying on the Earth and the Earth which is applying on the moon, are these forces same? And if they are same, why? Right? So we have to understand that thing and always consider this from the center, right? So we have to consider what are these forces? Are these forces equal or not equal? Okay. So the answer is they are same, they are equal. The force which Earth apply on the moon and the moon apply on the Earth will be same. It's neither greater nor smaller. They'll be equal because Newton's third law also states that, like each and every body, like there's equal and opposite force which acts on the body, right? So you can understand simply by that, remembering that rule too. So this is how in this case, both the things will be attracting with the equal force. And that can be explained with the universal law of gravitation too. Now, another simple question, calculate the force of attraction between two objects of masses 50 kg and 120 kg kept at a distance of 10 meters from one another. So what is given to us? Always in the numerical write the given thing. हमें मास दिया गया है, एक मास हमें दिया है 50 kg, एक मास हमें दिया गया है, say this is M1, this is M2, that is 120 kg. Okay, what else? Distance हमें दिया गया है 10 meter, and you have to calculate the force of attraction, that is F. You have to calculate G value. It's a universal constant. You know that it's 6.67 into 10 raised to the minus 11, right? And Newton, what is its unit? That is Newton meter square divided by kg square, right? If you don't remember also, you can simply see how you can remember the value, how you can remember the unit of this g. This will come here, so this will be meter square and this will be kg square. Now put the values here and you can find out the value of force. Simple. Now coming to the next part, let's see. Even if you want to calculate this thing, then you can, and the answer will come out to be nearly, say for example, f is equals to, I can put the values here, f is equals to 6.67 into 10 raised to power minus 11 into 50 into 120 divided by d square, that is 10 raised to power 10 square. Okay, so when you will solve this and just find out what answer you will get, you just have to do this calculation. Okay. Okay, another question for you. We have tried this. Now you have to think on your own. What happens to the force between two objects if the mass of one object is double? अगर एक object का mass आप double कर रहे हो, the distance between the object is double and tripled. एक बार आपने distance को double कर दिया, एक बार triple कर दिया. Double वाला हमने इसमें show करा है, triple वाले का भी आंसर अगर आपको याद हो तो हमने आगे वाले जब हमने बात कर रहे थे कि डिस्टेंस जब आप 2D कर रहे हो 3D कर रहे हो, we have done this in the same lecture. The masses of both the objects are double. अगर दोनों के masses को आप double कर रहे हो तो हमारे पास जो masses हैं, पहला मास जो हमारे पास है उसको भी आपने डबल कर दिया है, जो दूसरा मास है उसको भी हमने क्या कर दिया है, डबल कर दिया है, दैट इज ट्वाइस है. तो इस केसेस में हमारे पास में क्या फोर्स आएगा, व्हाट विल बी द फोर्स ऑफ अट्रैक्शन? यू हैव टू सिंपली यूज दिस फॉर्मूला एंड यू कैन फाइंड आउट द वैल्यू. So yeah, this is a very, very interesting app. Maybe in the next lecture I will discuss about this gravity force lab और आपको बताऊंगी किस तरह से आप इसके साथ प्ले कर सकते हो. Maybe I'll take few 10 to 15 minutes to tell you about this gravitation force lab. Meanwhile, you can try on your own basically this gravity force lab and this is on the PHET Colorado .edu. So try this on Google and you will find this gravity force lab. It's a beautiful, and you will understand how the equal forces, always the equal forces are acting on both the objects. And finally, coming to the last topic of this lecture, that is Kepler's law. Kepler's law, because it was given by Kepler, so it is called Kepler's law. There are three Kepler's law: first law, second law, and the third law, like Newton's law. So Kepler's three law of planetary motion, because they explain us about the planetary motion. So here we have three laws here that is related to the planet's motion of the planet. First law is that the orbits are ellipse. So they move in a ellipse, like they are moving in an elliptical path. Okay, so that's why we are saying the orbits are ellipse. Equal areas in equal interval of time. Say for example, here you can see it's a sun, right? As you can see here, it's a sun. Just give me a second here. Okay, so here it is a sun, right? And this is the planet which is revolving around the sun. So the time, say for example, it is moving, planet moving from here to here, it's taking 6 months. Okay, and when planet is moving from here to here, it is taking the same time, that is 6 months. So the area covered, this area and this area will be always same. This is a rule which was given by Kepler's. Second, third, first is related to the what is the shape of the orbit. Second, the time, related to time, that equal area in equal time. And finally, the third law states that, say for example, this is sun and the planet is revolving around this sun. Okay, so when this planet takes one complete rotation, that is called time to complete one orbit. Okay, this time period is obviously, I can see, directly proportional to the cube of the semi major axis, that is a cube. कितना बड़ा ये इलिप्स होगा उस पे डिपेंड करता है, राइट? अगर इलिप्टिकल पाथ बड़ा है तो उसको ज्यादा टाइम लगेगा उसको पूरा घूमने में. सो ऑब्वियसली दिस टाइम पीरियड, कितना टाइम लग रहा है एक प्लैनेट को सन के अराउंड रिवॉल्व करने में, वो डिपेंड करता है कि हमारे पास जो ऑर्बिट है, जो इलिप्स जो हमारे शेप में ऑर्बिट है, उसमें कितना टाइम, इलिप्स जो पाथ है वो कितना बड़ा है, राइट? So why it is important basically here is that Newton used this Kepler's third law to calculate the gravitational force of attraction. तो Newton Kepler's law पहले इन्वेंट कर दिए गए थे, उसके बाद में न्यूटन ने ग्रेविटेशनल फोर्स ऑफ अट्रैक्शन जो फॉर्मूला डिराइव किया था वो इसी के हेल्प से किया था. Okay, so finally the conclusion. What we have learned in this lecture. So we have learned about the dependence of gravity on mass and distance. किस तरह से वो mass पे depend करती है, किस तरह से distance पे depend करती है, importance और application क्या है universal law of gravitation की, and finally we have studied about a bit about the Kepler's law. Okay. So obviously, what is coming up next? So in the next class, we are going to study about, maybe before that, I will discuss about the app, which I have already was telling you in this class. And after that, there will be a lecture which will be coming on the free fall. Okay. So in this free fall, we'll be studying what is acceleration of freely falling object. Any object which is falling freely, what is its acceleration? Or किस तरह से velocity चेंज होती है फ्रीली फॉलिंग ऑब्जेक्ट की, सेम रहती है या चेंज होती है जब वो ऊपर जाता, कोई ऑब्जेक्ट आप ऊपर थ्रो कर रहे हो और जब वो नीचे आ रहा है, व्हाट हैपेंस टू इट्स वेलोसिटी. Okay, stay tuned. Signing off for now, and I think that's it from my side. Thank you. Bye bye. Take care.